Hi, thanks for coming to take a look at Watershed Walk Day 1. These are our notes for Day 1. So during class, we want to make sure that everyone has a sharpened pencil, and you do need your aquatic ecosystem packet during class today. So we're going to answer the questions below. List the 4 kingdoms under the domain Eukarya. So you have to think back to when we first talked about classification. Classification, we have 3 domains, and one of our domains is Eukarya. In those 4 kingdoms, we have Animalia, Plantae, Fungi, and Protista. So those 4 kingdoms are the things we're going to be thinking about in creatures that actually have real nuclei. They all have a real nucleus. All right, which kingdoms are represented in our ecosystems so far? That would be Animalia and Plantae and Protista. Right now, the Animalia we have is Daphnia. The Plantae that we have duckweed and we have Elodea. And our Protista are Chlamydomonas and Spirogyra. So that's what we've got in our systems right now so far. Which plants were added to our ecosystem last time? That was Elodea and duckweed. So you had to think about how that might change your pH or how it might change any one of the water quality indicators. We made predictions in our packets last class. So how might this change the pH? It might actually make our water in our ecosystem become more basic because plants remove carbon dioxide from the water. Carbon dioxide makes our water acidic. So if we remove that carbon dioxide, our water will become more basic. Remember, basic are the numbers greater than 7. Acidic numbers are lower than 7. By the end of today or by the beginning of next class, you want to make sure you've completed the watershed intro slides. And we'll also have some slides on our new creatures that we've just put into the ecosystem that you want to go ahead and get taken care of. All right, so would you rather zip line or whitewater raft? Think about that. That's a discussion topic we had in class. And here's what we're doing today. What are we going to do? We are beginning our next lab, which is the watershed walk. And so we're going to do additional work with our model ecosystems and talk about watersheds. How are we going to do that? We're going to continue with our water quality indicator testing, and we are going to do some research into creatures that we have in our ecosystems, and also we're going to do some research on watersheds in our area, and we're going to use some models to demonstrate what we know and how we know it. Why are we doing this? It's so that we understand the features of a watershed. So, if you're in the classroom looking around, can you see anything new about your ecosystems? It's animal time. We have added pond snails and we've added guppies. Our guppies are not these fancy-tailed guppies. We have plain guppies, but there are guppies and pond snails in our ecosystems now. These are both animals. All right, so please turn to this page in your packet. We're going to the data table monitoring, and we've already filled in testing information for our baseline, which was day 0, day 1, and then day 2. So now we're on day 3. And for my odd classes, it's going to be October 10. For even classes, it's going to be October 11. So please find the room temperature for your class period written up on the board. And if you are absent, you're going to make sure to get this information, all of the testing information from your table mates, not just your classmates. You want this information from your table mates. Okay, so room temperature would go in the white box, and then we're going to find out who has which jobs for today to fill in all the other boxes. All right, so here's our jobs for today. If you were absent, again, somebody else did your job during the class day, and so you just need to make sure you get your data from your table mates. All right. So, of course, we always wear goggles when we go to our stations, and we are always going to use the directions on the card. So going up to the pH tester and the DO tester, you're using your card, you have it with you. And if you are staying at your station testing nitrites, you're using the card to remind yourself about exactly how much you need. Remember, when you're taking water samples, try not to get any of the organisms, particularly the plants, the duckweed and the Elodea. The other creatures are going to try to stay clear of your sample container. So you're probably okay there. All right. So after testing, go back to your table. This is actually day 3 that we've just done, but you're going to get all of the data and then consider what changes you saw from today compared to last testing day. And then see if you can make some inferences about why those changes happened. Go ahead and check in with your table mates when you do this. All right. So then finally, we have now completed at least 2 days worth of our daily reflections. The first day we considered how any 2 organisms in the ecosystem might be interacting. And since we had Daphnia, which is an animal, and we had 2 algae, the 2 algae were Spirogyra and Chlamydomonas, we can guess that probably the Daphnia was eating the Chlamydomonas. You might have said something about the algae producing oxygen and the animal Daphnia needing some oxygen. You might have said that. That would be okay too. All right, our day 2 question asked about what we would predict as a consequence or some effect that happened now that we have 4 producers in our ecosystem. And so hopefully you made a prediction about that last class. And after you've done all of your measurements, look at that prediction that you had made for day 2. Were you correct? Why or why not? So think about if you were correct, that's probably a good sign that you were thinking about what those producers might have done to your water systems. But if you weren't correct, what might have changed? What might be different? And talk around your table mates, or if you were absent, check in with your table mates when you see them so that you can try to answer your daily reflections for our day 3 of testing, which is actually, it's not October 5. Sorry, I'll change that. It's after October 10 and October 11. I'll change that. Sorry about that. All right. So now we want to be on this page in the packet. You already have 5 things listed on this page, so you may need to flip the page over to add your next items. Currently, we have Chlamydomonas, and we have Spirogyra, we have Daphnia, we have Elodea, and we have duckweed. So we're going to be adding today a guppy and a snail. So to do that, you're going to go into Schoology, into today's folder. And you're looking for WW, that's Watershed Walk, WW Day 1, and it'll say guppy and snail organism information or something like that. So please fill out your page with the classification information on these organisms. Don't forget to draw a picture. And then, of course, toward the end of your packet, you have a big picture of your aquatic ecosystem. You should already have 5 pictures that represent the things we've got in there already. And now you're going to add a guppy and a snail. Okay. In class, we spent a moment to see if we could find 9 differences here. You can pause the video and look for them. Pause now, and I'm about to flip over to the answers. Okay, there's our answers, 9 different things that were different. And so we're starting our new section of this lab work. This is Watershed Walk. So we're going to explore the Chesapeake Bay watershed system. That is the watershed system we are in. Well, what's a watershed? I guess we need to figure that out. So, has anyone been to the Chesapeake Bay? We'll discuss that in class a little bit. Chesapeake Bay is a body of water that is adjacent to the Atlantic Ocean. And we'll talk more about that. So if you've ever seen one of these contraptions, you're going to think about what happens once you drop a marble into it. So we're going to watch a little video here. I'll let it play. There's no sound for it. All right, so hopefully what you noticed was that no matter what, if we put a marble in at the top, it worked its way down. Sometimes they took a slightly different. I'm still recording. I apologize for my small technical difficulty there. So we're going to keep in mind that if you put a marble at the top, it's going to work its way all the way down. And we're going to think about that in terms of water on land. All right, so again, regardless of where you place the marble, where will it go? It's going to work its way down to the bottom of the whole system. All right, so today we're going to do some research about watersheds. And so you're going to go into Schoology and find the WW Day 1 Watershed Introduction information. And you're going to go through that independently. Make sure you submit these slides at the end of your research so that you can get that Schoology assignment off of your to-do list. All right, so once you've done that assignment, you're going to come back here and we're going to have a quick review. So is a watershed land or water now that you've looked up information about those watersheds? All right, here's our watershed. Remember, we're looking at where does the water go once it falls onto the ground. And remember, we have a divide right here where this is the highest point. Some water is going to go off that direction and some water is going to come off in this direction. So a watershed is actually the land. We are talking about the land when we are saying watershed. So again, here we have the highest points. And when we have rain or precipitation of any kind, if it falls inside this divide, it's all going to come down to the same basic body of water. Okay, you can see that water will also go to the other directions. Those are different bodies of water at the end of their watershed. So this is a different watershed over here, and this is a different watershed over here. We are looking just at our main watershed in this picture. All right, a watershed is an area of land that drains into a common body of water. So if this is the watershed, it is defined by the dashed yellow lines here, and any water or precipitation that comes down is going to eventually funnel down into this body of water. All right, what is this? Where does it go? Well, this is a storm drain. Storm drains just lead to the nearest waterways. They go straight to the nearest waterway. Streams, creeks, rivers. And so which body of water around us is eventually the recipient? For us, it's the Chesapeake Bay watershed. All right, there are 6 states that will have some land that drains into the Chesapeake Bay. Think about that. 6 states are having land that when it gets rains or snow, that precipitation is eventually going to come into the Chesapeake Bay. All right, so the 6 states that we're going to think about are, if you look at this picture, part of New York right here, Pennsylvania, part of Pennsylvania rather. We have Maryland, most of Maryland comes in, bits and pieces of West Virginia, some of Virginia, little tiny bit of Delaware, and of course Washington, D.C. So we're going to have all of those areas that when they have precipitation on them, it's going to drain into our Chesapeake Bay. All right, so please go into your Schoology folder, and now you're going to complete your exit ticket. You always get 2 attempts, and I'll take the highest score, but if you don't get 100% on the first attempt, check and see what might not have gone right, double check your notes, and try to get 100% on the second try. Thanks for watching.